we're going to begin rotations. There's two ways to rotate. You can go clockwise or counterclockwise. These are the abbreviations. CW stands for clockwise. That means we will travel in the same direction as a clock. So if we start at 12 o'clock, we'd move to 3, to 6, to 9. So we will be moving in that direction. If I start with a shape or a point in quadrant 2 and I rotate 90 degrees clockwise, it should end in quadrant 1. If I start in quadrant 3 and move clockwise, it should end in quadrant 2. Please take a moment, graph triangle A, B, and C, label your vertex, your corners. Pause the video, draw the triangle, and label. Thank you for pausing. Take a moment. Do our triangles look the same? Are they in the same spots? Okay, I am going to rotate clockwise, so sometimes I like to say to myself, when I'm done drawing this, what quadrant should the shape land in? Well, if I start here and I have to rotate clockwise, I'm going to put a little X. My triangle should end right here because that would be 90 degrees clockwise. A trick I learned, because I am not very spatial, I am moving clockwise, so I am going to rotate my paper 90 degrees counterclockwise. So now the 3 is at the top of the page. I'll show you what I mean again. I start with a 12. I'm going to turn my paper 90 degrees, so that's one turn counterclockwise. So now the 3 is at the top. I will use these given ordered pairs and regraph them. This has become my X. That has become my Y. So my point A is the point 3, 6. So 1, 2, 3 to the right and 6 up. That becomes A prime. B is 5, 3. So 5 to the right, 3 up, B prime. C, 2 to the right, 1 up, C prime. Do your best to draw a straight line. Mine is hideous. Now, if you rotate your paper back to the original, notice my shape ended in the quadrant I wanted. Take a moment, pause the video, write the ordered pairs for A prime, B prime, C prime. Please pause the video. Then as you're doing it, what do you notice about the two ordered pairs? Thank you for pausing. Take a moment, compare your ordered pairs to mine. What do you notice? If this was my original X and that's my original Y, what does it look like here? If that is my original X, that's my original Y, what do you notice there? And the same for C. So the rule for any ordered pair XY, any numbers I give you, and I didn't have a graph, but I wanted to know where the points would end, what do you notice happening here from here to here? What do you notice? I noticed two things. First, I noticed that the X and Y switched places. 3 came first, 3 came second. 6 second, moved to first. So the Y and the X switched spots. Oh, but look at what also happened. It looks like it took the opposite. You can't say negative. That means opposite. So it went from positive to negative, etc. That is a clockwise rotation. Now we're going to move to a counterclockwise rotation. This time, we'll start with 12, your 3, your 6, your 9 o'clock, and we're going to go the opposite way that a clock would move. So if something started in quadrant 4 and I went counterclockwise, it would end in quadrant 1. Please take a moment, pause the video, graph your next triangle. Thank you for pausing. Please compare your triangle to mine. Did they end up in the same spot? So with this triangle, we are going to go counterclockwise, which means if it starts here, I'm going to put a star. I need it to end up over there because it's going to go one turn, 190 degrees in the opposite direction of a clock. So how I have to do it, because I'm not very spatial, I can't just visualize this. I turn my paper clockwise. I will use these same ordered pairs again and graph. So please graph your new triangle and list your new ordered pairs. Again, graph the triangle, list your new ordered pairs, pause the video. Thank you again for pausing. Let's just take a brief moment to compare our answers. Here's my original triangle. That is what mine looks like after a 90-degree counterclockwise rotation. I listed my ordered pairs. So again, if this is my original X and my original Y, what do you notice is happening? I noticed two things. The Y and the X flopped spots, and I noticed my Y's were all the opposite. Please don't say negative, it is opposite. Meaning if I started here and rotated, it could go there. It's not opposite. It is opposite, not negative. Another rotation that we're going to talk about today is 180 degrees. So if I start in quadrant 1 and I go 180 degrees, I could go clockwise, 90, 180. If I started in quadrant 1 and went 180 degrees counterclockwise, 90, 180, notice I will be in the same spot. Rotating 180 degrees, you can go clockwise or you can go counterclockwise. It does not matter. Please take a moment, pause the video, graph your triangle. Thanks again for pausing. Let's just take a moment and make sure our graphs look the same. It's the same triangle. I hope you know that it should all look the same. So I'm going to do 180 degrees. It doesn't matter what direction I go. I'll turn my paper one turn. That is 90. Turn again. I've done 180. So in theory, we had 12 o'clock here. We have our 6 o'clock at the top. I spun it 180 degrees. I will use my same ordered pairs. This is the X positive. These are my Y's positive, and graph that triangle again. So 5, 3, and 2, 1. You usually can make okay straight lines, but today's been rough. When I rotate back over, that worked beautifully. I am 180 degrees away. So now we're going to figure out our ordered pairs. To get to point A, I would move left 3, down 3. So now I have the point -3, -6. To get to B, I would move left 5, down 3. So -5, -3. Point C, I would have -2, -1. So again, looking at the original ordered pair here, what are we doing to get to the next ordered pair? What pattern have you noticed? Well, if I give you an ordered pair, what I noticed, they didn't switch order, like it's XY, 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 XY. So it doesn't switch orders. But I noticed positive to negative, positive to negative, ooh, positive to negative. So we took the opposite of the X, the opposite of the Y.